Hello, in this tutorial I want to show you how to use AIDeveloper for transfer learning. AIDeveloper is available on this GitHub page as well as all the data I have used for the tutorials. To perform transfer learning, you first want to train a neural net or some model on a different dataset. I chose to basically follow tutorial number 1 and train a convolutional neural net on the entire 10 classes of Cypher 10. Let us have a look at the performance of the resulting model using AIDeveloper and the History tab. So we just load the history of this model, which is saved in this folder here by loading the meta file, and let's display the accuracy and validation accuracy. As you can see, the maximum validation accuracy is reached at this model and is approximately 83%. This particular model is located here, and we will use it to continue training on a different data set. I chose Fashion-MNIST from Zalando, which is a dataset consisting of 10 different classes of images from fashion items like trousers and t-shirts, bags and shoes. In total, there are 60,000 images of a size of 28 by 28. The images in Cypher 10 are 32 by 32 pixels. We need a model which was fitted on grayscale images. But first we need to load the Fashion-MNIST dataset. Just push this download button and save the zip file. Let's view this file. Where is it? There you go. Unzip it. So in this folder, you see that there are two CSV files. We will need them, so I cut and paste them. And if you open them, you will see that there are no images inside. Instead, there are lots of rows. In each row, you have one image. The first column is the label for this image, and the following columns describe the pixels of each image. As there are 28 by 28 pixels in each image, you have in total 784 pixels. So now we basically need a little Python script which converts these CSV files to PNG images. And I already wrote this script, which you can also find on my GitHub right here. You just run this script and it will open first the test set and create a folder for test, and then all the folders for the corresponding classes with the PNG images inside. Next, it will also create the training set, and this takes a little bit longer since there are more images, obviously. And I decided that we just manually drag some of the images to a separate validation set. So now we can basically go ahead and load the folders into AIDeveloper. These files you can also find on my GitHub. Okay, nice. So by default, as you can see, AIDeveloper assumes that you want to shuffle your data. This would mean that you take a random 100 of your 200 images for validation. But we want to use all 200 images for validation. And for training, let us use only 1,000 images during each epoch. We can have a look at the overview window if everything is fine. So we have 1,000 images for each class and training and 200 for validation. This looks good. Now let's load and continue to train a model. This is the model we want to load, right? And it will ask me what was the normalization method I used for the previous training. Either I load the meta file and AIDeveloper will read the normalization method automatically, or we can select the normalization method, and here I know that I have used a division by 255. I can also use a different normalization method, but then transfer learning wouldn't work well. As you can see, there are large tooltip annotations, and if you don't like them, you can also switch them off by just unchecking this option. So as you can see, the input image size automatically went to 32. This is because this model here was trained on Cypher 10, which contains 32 by 32 pixel images. So now we basically have two options to correct the image sizes. Currently, our images are 28 by 28 pixels. We could either do zero padding, which means we pad a frame which is 2 pixels wide on each side, giving 32 by 32 pixel images as a result. Or we do a zooming operation. Both you can actually do with AIDeveloper. If you just go ahead and train it as it is, it will automatically do zero padding. But you can also use this zooming option. If you compute 32 divided by 28, you will get 1.14. That means if we scale up our images by 1.15, we will get zoomed images which are approximately 32 by 32 pixels in size. I would like to start with no augmentation. The images look like this. But we want to do transfer learning. And one option that you have in AIDeveloper is to only train the last n layer. So let's say we only train the final layer of the neural network, which means we train the last one layer. And then we just need to define a path where we want to save the new model. I already created this folder. In order to see a little bit more what is going on under the hood of AIDeveloper, you always have this window here. And if you go to Edit and hit Verbose, you will see a little bit more what is going on under the hood. So let's now check Initialize and Fit and start fitting. One epoch takes 18 seconds. While this is fitting, I can show you some benchmark results for this Fashion-MNIST dataset. First of all, on this Zalando site, they hint me to a benchmark dashboard. And as you can see, the highest accuracy they reached here was approximately 90%, and it took them more than an hour training time to reach this. Furthermore, I found 3 papers which used Fashion-MNIST. This paper here on arXiv, they also reached accuracy values of approximately 89%. Then this paper, there they reach error rates of down to 9%. This translates into accuracy values of 91%. And last but not least, there is this paper, also from arXiv, and here they reach accuracy scores up to 91%. So this is approximately what I would like to achieve today. This model is not really learning anything, so I guess I should allow the model to use more parameters. This basically means that I increase this number to 2, which means it's then allowed to use more layers and more parameters of the model. We apply this at the next epoch, and then let's see what happens. As you can see, now the model was updated. Request for custom trainability states, train only last 2 layers. And this is the summary of the model. And now we have 64,000 non-trainable parameters and more than 400,000 trainable parameters left. And it continues to train. Now training should take just a little bit longer. Let's give it another layer to train on. Apply at the next epoch. So now this is the new summary, and we have in total 28,000 non-trainable parameters and 450,000 trainable parameters. Training now takes 22 seconds per epoch. Let's use this time to review the CNN we are currently fitting. We have the input layer, a convolutional layer, rectified linear unit, another convolutional layer, and so on, a max pool layer, a little bit dropout, and so in total there are 4 convolutional layers and 1 dense layer, followed by another dense layer, which is the output layer, which contains as many nodes as there are output classes, 10 in this case. Right, so this is the network which we are currently fitting and which was also fitted previously using Cypher 10. Currently, we are training only the last 3 layers, and when we have a look at the last summary, that would be including parameters from this layer, and this layer, right? So these numbers, so this value plus this value plus this value, equals to this 450,000, which is the number of trainable parameters. All the layers before, which is this one, and this one, right? They are not trainable at the moment. So, but now, as the model is not learning much anymore, I would like to also set them to trainable, but this would maybe cause it to overfit because there are so many parameters available now, and as we can see, the accuracy and validation accuracy are already pretty close. Therefore, I would like to use a little bit of augmentation by using horizontal flipping. And now I can switch off this expert mode, which means also this option is switched off. And let's apply this at the next epoch. This will of course mean that we are fitting on all parameters, which prolongs the training time. As you can see here in this newest summary, we have a total number of parameters of 477,000, and we're basically training all of them now. While this continues to fit, I think I could explain again what this shuffling option here means. For the validation set, I switched it off because I'm not interested in shuffling, but here it basically draws 1000 images. It could mean that I draw several images twice or 3 times and some images not at all, so we have a random sample of our actual data set. This is really helpful, especially if I have a very unbalanced data set. I can create a balanced data set, but if you don't like it, you can just switch off shuffling and use all the images that you have in each epoch. I would actually like to now use all the data that we have in an epoch. That means I would like to switch off shuffling for the training set, but this is not possible during fitting. So my only option is to stop fitting. Now the fitting finished. And now I would like to switch off shuffling entirely. Let's update the data overview box. We are now using 5,800 images for each epoch. And let's call this model number 2 and load the last model. We use division by 255, and that's it. We can continue. So I forgot to switch off this expert mode. I'd like to switch this off at the next epoch to train the entire model on the entire dataset. In the meanwhile, I can explain one more thing. So you might remember that I wanted to apply the zooming ratio in order to obtain 32 by 32 pixel. Apparently, you could use different interpolation methods, and you can actually change the interpolation method here under options zoom order. I currently just have nearest neighbor, but you could also use a linear interpolation or something different if you like. since fitting is going pretty slow, I would like to reduce this loss dropout rate. We now have 25% dropout at each dropout layer. Let's check how this performs. Maybe we can beat the current best 92% accuracy. So as you can see, we are consistently underfitting. So I guess the best idea would be to, again, reduce the dropout rate at every dropout layer at the next debug. So I think we have reached already a pretty good model here with an accuracy at 93%. And for the sake of this tutorial, I will let it run. And in the meantime, I go ahead and use this model for assessment of the validation set. So currently in this table here, we have loaded the training set and the validation set. First of all, we have to clear this list. And next, we want to drag in the testing data. And we want to use the entire data set with no shuffling. So when you have done this, you can also check in the data overview that everything is correct. And now in the Assess tab, you can see the exact same data being represented here in this table. And we now load a model and apply this data. Load model number 12. Perfect. We can check the inference time of our model, which is 1.8 milliseconds for each image. And now let's apply the model to this data to check the testing accuracy. Okay, so now the testing accuracy should be pretty bad. Yeah, it's just 87.91. Why is that? Okay, to realize what happened here, we can go right here. It says, while it was loading, I will pad 2 pixels on each side. This is because we have a zooming factor of 1. So the images are too small and it has to pad 2 pixels on each side. If I zoom in, then the model should work much better because this is the way we fitted the model. And hit again, update plots. Now it loaded the images and it does not need to crop any pixels or pad any pixels. And as you can see, now we have an accuracy, which is the testing accuracy of 92%. So this is already pretty good. This is better than reported in this paper. And what have they got here? 91. So we are actually already better than those papers. All those confusion matrices you can just add to a clipboard by clicking here. Then there's also information. The confusion matrix is appended to a clipboard, and it could be pasted into an Excel file in order to copy the classification report. You just click somewhere into this region and it will also be appended to the clipboard. Then you can paste it and save it somewhere. Okay, that's it for this tutorial. Thank you for watching. I hope you find this helpful and have fun with AI Developer. Bye.